For the majority of my professional career, I routed and designed hot ductwork between vessels and pieces of equipment in refinery process units. This project is specifically showing the ductwork, supports, and spring hangers in an FCC unit. The main unit in a refinery that makes gasoline, diesel, and jet fuel is the fluid catalytic cracking unit. It is called the FCC unit. In the industry, it is the cat cracker. Here I am showing 3 of the main vessels associated with the FCC. From left to right, the short vessel on a concrete pedestal is called the third stage separator. It is sometimes called the TSS. The center vessel is the regenerator. The tall vessel on the right is the reactor stripper. There is another important vessel in the FCC, but it is not shown in this model. That vessel is the fractionator. In this view, the fractionator would be located on the right side. Ductwork between the vessels operates at high temperatures and thus requires engineering, careful planning, stress analysis, and sometimes finite element analysis. Steel expands as it gets hot. A ductwork designer must take this expansion into consideration. Chrome alloys and stainless steel can handle much higher temperatures than mild steel, but they have different expansion rates and their cost is much higher in comparison. For example, carbon steel duct at 350 degrees Fahrenheit will grow approximately 2.26 inches per 100 feet of length. A stainless steel line at 1200 degrees Fahrenheit will grow 14.2 inches per 100 feet. Process temperatures are the temperatures on the inside of the vessels and ducts. The temperature at the shell is called the design temperature. I've shown the names of the transferred ducts and their design temperatures. The hot process temperature can be isolated from the shell by adding internal insulation. All ducts shown at 650 degrees are refractory lined. Internal refractory is like concrete and weighs about 130 pounds per cubic foot. A 42-inch ID duct with internal refractory weighs about 1,011 pounds. It's clear that supporting the weight of these ducts and controlling their movements is an important design consideration. The pink-colored rings on the ducts are Rilco clamps. The Rilcos have insulation between duct and the clamp. The support springs, struts, and snubbers attached to these clamps. The supports on this project are anvil constants. Each of the springs you see here support about 19,000 pounds. The hydraulic snubbers are supplied by Rilco. A constant support is a spring that maintains a constant load even while the duct is moving. The lower part of this vertical duct moves as much as 6 inches downward as the line heats up. Shown here is a Type F constant support. They are used for upward thrust. Between the duct and the top of the spring, there is a specially designed slide plate that allows free lateral movement without binding. Struts, guides, and snubbers keep the line from moving too far in any direction. The short line between the reactor and the regenerator is called the spent cat standpipe. It consists of an expansion joint and a slide valve. The expansion joint is very complicated because it must accommodate the upward movement of the regenerator on the left and the downward movement of the reactor on the right. The regenerated catalyst standpipe on the left and the long vertical riser below the reactor were not part of the project scope, so I did not model the line details and spring supports. The overhead line from the regenerator goes down to the top of the third stage separator, the TSS. The other line coming out of the top of the TSS is the line to the turbo expander. Only a short portion of that line is shown, as the tie-in to the expander was not part of this project. Exiting below the third stage separator is the catalyst underflow line. This line has a potential for cycling very hot 1100-degree catalyst fines. For that reason, the line is 304H stainless steel. This high temperature presents challenges to the stress engineers. One of them told me, "This was one of the most difficult stress jobs I've ever worked on. The line was so soft that it was like a single piece of cooked spaghetti." For me, as the designer, that meant I had to strategically locate constant supports with slide plates, struts, guides, and snubbers. I had to coordinate with our structural designers to locate hard supports for my anvil components. This is a typical arrangement for the cat cracker section of an FCC unit. Sometimes the reactor and regenerator are arranged differently. Some units don't have a third stage separator downstream of the regenerator. As of early 2026, there are 131 operable crude oil refineries in the United States with a distillation capacity of 18.4 million barrels per day. The Gulf Coast, primarily Texas and Louisiana, dominates U.S. refining, accounting for over 50% of total throughput.